Today's topic is about 15 cost-saving strategies in cooling and ventilation. Let's start. Operational costs in industries are rising faster than ever. Electricity costs are increasing. Maintenance expenses are growing. Production pressure is higher. And industries are expected to deliver more efficiency with tighter margins. So the question is, how are smart factories staying competitive? The answer is simple. Smart factories are not just focusing on production. They are focusing on operational efficiency. A properly engineered ventilation and cooling strategy can reduce energy costs by 20 to 60%, while simultaneously improving worker productivity, equipment reliability, and thermal comfort. Here are the major strategies through which cooling and ventilation optimization reduces energy cost on industrial shop floors. 1. Right-sizing equipment instead of oversizing. Many factories install oversized exhaust fans, air coolers, blowers, or HVAC systems for safety. Optimization strategies. Recalculate air changes per hour, ACH. Heat load. Sensible heat gain. Occupancy load. Process heat load. Replace higher horsepower fans with optimized lower horsepower, EC fan. Multiple large blowers with distributed smaller systems. Result: 15 to 40% motor energy reduction. Lower demand load. 2. High efficiency fan models. Traditional industrial fans are highly inefficient. Better alternatives: EC fans, electronically commutated. Direct drive fans, backward curved centrifugal fans. Aerodynamic axial fans, HVLS fans. Energy saving mechanism: higher airflow per watt. Reduced transmission losses, lower current draw. Savings: 30 to 50% reduction in fan energy. 3. Ventilation, zoning instead of full shop cooling. One of the biggest mistakes in factories is treating the entire shop floor equally. Problem: heat generation is usually localized. Furnace section, press shop, welding area, DG room, compressor room. But ventilation runs everywhere. Strategy: create thermal zones, hot zones, moderate zones, occupied work zones, storage zones. Implementation: independent exhaust circuits, dedicated fresh air supply, variable fan operation, smart dampers. Result: avoids overventilating low load areas, lower connected load, reduced cooling tonnage. Savings can reach 25 to 45%. 4. Spot cooling instead of volume cooling. Cooling air volume is expensive. Cooling people is cheaper. Traditional mistake: trying to reduce overall shop floor temperature from 42 degrees Celsius to 30 degrees Celsius. This requires huge energy. Better strategy: provide localized comfort, air jets, spot coolers, ducted air throw, pedestal circulators, air showers, task cooling stations. Result: workers feel comfortable even if ambient remains higher. Energy impact: 10 to 20% of the energy, compared to full shop HVAC. 5. HVLS fans. Instead of number of smaller fans, factories often add more fans where the issue is poor air movement. Now HVLS fans are a better choice provided the installation is not a constraint. HVLS benefits: improves evaporative cooling effect on skin, breaks thermal stratification, reduces stagnant zones. Energy comparison: one 1.5 kilowatt HVLS fan can replace multiple pedestal fans, several wall fans, partial cooler load. Result: perceived temperature drops by 4 to 7 degrees Celsius without actual refrigeration. 6. Using air coolers instead of air washers where feasible. Many factories install centralized high-capacity air washers. Air washer problems: large pumps, duct losses, high maintenance, higher water usage, large blower motors. Best application: semi-open industrial spaces, warehouses, fabrication shops, assembly units. 7. Demand-based ventilation using sensors. Most ventilation systems run all day. Waste: heat load varies continuously. Solution: sensor-driven control. Temperature sensors, humidity sensors, CO2 sensors, TVOC sensors, occupancy sensors. Automation: use IoT-based controls. Typical savings: 20 to 30%. 8. Variable frequency drives, VFDs. Running fans at full speed continuously wastes power. Fan affinity law says power varies with cube of speed. Means if speed reduces by 20%, power reduces by half. Applications: exhaust fans, cooling tower fans, blowers, air handling units, massive electricity savings. 9. Natural ventilation integration. Mechanical ventilation should assist nature, not fight it. Strategies: ridge ventilators, turbo ventilators, roof extractors, louvers. Benefit: removes trapped hot air naturally. Result: reduces exhaust fan runtime, cooler load, HVAC load. 10. Thermal stratification management. In tall factories, roof temperature may exceed 50 to 60 degrees Celsius. Heat accumulates at ceiling. Solution: roof extraction, HVLS fans, ridge exhaust, destratification fans. Benefit: prevents downward heat radiation and trapped heat buildup. 11. Heat source isolation. Instead of cooling the whole factory, remove heat at source. Techniques: local exhaust ventilation, LEV, hood extraction, furnace canopy extraction, welding fume extraction. Result: heat never spreads across shop floor. This reduces cooling requirement drastically. 12. Hybrid cooling strategies. Instead of depending on one system, combine natural ventilation, mechanical exhaust, HVLS fans, spot cooling, evaporative cooling, roof insulation, Y-effective. Each system handles part of thermal load. This reduces dependence on energy-intensive systems. 13. Time-based operational logic. Not all systems must run continuously. Strategy: sequencing, staggered operation, shift-based cooling, occupancy-based control. Example: loading area fans off during idle periods. Coolers on only during worker occupancy. Result: direct reduction in kilowatt hours. 14. Roof heat reduction to reduce cooling load. A major portion of heat enters through roof. Methods: roof insulation, solar reflective coatings, false ceiling, double roof, ventilated roof. Impact: can reduce internal temperature by 3 to 8 degrees Celsius. This dramatically lowers cooling energy demand. 15. Smart airflow engineering. Cooling failure is often airflow failure. Techniques: CFD-based airflow design, directed airflow pathways, avoiding short-circuiting, air balancing. Benefit: less equipment required for same comfort. The result is not just lower operational costs. With these measures, smart factories achieve better energy savings, higher productivity, improved worker conditions. In today's industrial environment, efficiency is no longer optional. The factories that optimize their light, air, and energy systems today will lead the industries of tomorrow. If this perspective helps you think differently about your factory, then hit the like button, subscribe to the channel, and share with your team. 5-star technologies: creating productive and efficient shop floors.